used any of those app servers, by the way, Wildfly, that's, if you don't recognize that, that's a new name for JBoss. You've got the two big boys there, WebSphere and Oracle, and a host of others, and it's by no means an exhaustive list of app servers. But if you haven't used any of those, then, well, there's a bit more. So is this talk for you? Do you write Java SE or Java ME applications? Well, then there's definitely a takeaway for you from this talk as well. Do you use another JVM language? You use Scala or Clojure or something like that? Then definitely there's something that you can use from this talk. Do you have to look at log files? So be this Apache log files, Nginx log files, IIS log files even. Then definitely there's something for you here. And if none of these apply to you, then I'm sort of a bit concerned at what you are doing at this talk, and I'd like to have a bit of a chat with you and find out. But then I've got this for you. That's about the best I can do. So first off, let's keep to the bare basics. Log files. So log files. But log files are basically the Swiss Army knife of app server troubleshooting. Before you, and if you don't have something like Andreas's Dynatrace, then definitely this is your first port of call. And even if you do, it's still the first port of call. That your log files are basically your guide to what's going on in your app server. So first off, understand that or make sure that you understand your abstraction layer that you're using. So is this something? Are you using commons logging or SLF4J? And usually this is determined by your app server, but usually you can plug in various implementations if you want. And then make sure you understand your log framework. Are you using log4j? Are you using the JDK logging? What kind of logging are you using? Like Andrea said, make sure you've got the right logging in up front. So write your code with the logging, because by the time that you actually need the logging, the code's already in production, and to now do another deployment to find out what's going on, that's not feasible. So make sure up front you are able to get the things that you need to know. Log file analysis. So you can keep it very simple. I mean, this is something that just to get a feel for what's going on, you can just open it up in a text editor. So that's kind of the very keep it simple method of app server troubleshooting. Then if you want to get a little bit more advanced, you can brush up on your command line foo. So first off, what you can do is you can have a look at things like your normal bash commands. You do a VI, get your server logs, or have a look at your server logs. You can do a grep. In this case, I'm searching for the word stuck. So I'm searching 2 lines before and 10 lines after each occurrence of the word stuck. And in the last one, it's 10 lines around the occurrence of the word stuck, or socket read. So why am I searching for the word stuck? We'll get to that in a short while. Then moving on to some blue belt command line foo, something a little bit more complicated. Can anyone here tell me what this will give you? IP address. That's right. Sorted in reverse. Excellent. You work at Amazon, right? Cool. And then we're moving on to something a little bit more hectic. So this is your black belt command line foo. Any takers for this one? What's going to happen when you run this guy? Can I break this? Can I break the suspense? So what it will do? I think you're on the right track there. So it'll basically print out a histogram of the occurrences of the word stuck in your log file. It's also sorted in order of most frequent to least frequent occurrences. So yes, so command line foo, definitely a lot of times you don't necessarily have access to other tools. You can only SSH into the machine, into the box, and you need to brush up. AIX, exactly. So you need to know these things. So make sure you know this. But then there are easier ways, and this has been mentioned a couple of times already. So you've got tools like Splunk and Elk. So the Elk stack, that's Elasticsearch, Logstash, and Kibana, all produced by the same company. They've gone semi-commercial now, but you still get the open source tools available for free. Splunk not so much. So how does Elk work? So you've got a log file, and then you've got a log forwarding agent that you install on your server that it forwards the logs to Logstash. Logstash persists those logs, and then Elasticsearch runs on over that persisted log files that's been broken up into various fields, and it indexes your log files for you. And from there, you've got Kibana, that is the front end for analyzing your log file. So what does it look like? So there's the front end for Kibana. You'll see over there you can, apologies for that. You can do a query at the top. This is Apache Lucene compatible queries. Sorry, let me just disable the Wi-Fi. Seems to be all right now. Okay, so you've got, like I said, so you can search for any Apache Lucene type query and find the occurrences of the word stuck in your log file. So still I'm looking for that word stuck. It also prints out a nice histogram for you, which gets me to why are we looking for the word stuck. So stuck thread detection, that's one of the sort of very bare bones techniques in troubleshooting. And basically what it indicates to you is you want to know if threads in your server are doing a certain bit of work for longer than X amount of time. And most of the app servers support this in various ways. For example, Tomcat has a stuck thread detection valve that's got a threshold of 60 seconds, so anything over 60 seconds will be reported. And they've got something unusual in that they also try and interrupt the thread at a certain threshold, which may or may not work because not all threads are interruptible. And also bear in mind that if you do interrupt the thread, you can leave the program in a state that's inconsistent. So just be careful with that kind of thing. So what happens when you encounter a stuck thread? Well, you get something like this in the log file. So at this point, it hasn't interrupted anything yet. It just prints out where that thread is right there at that point of execution. All the app servers support this kind of thing. The one I'd also want to highlight is, I'm not going to go through all of them, but WebSphere, they've even got a mechanism. So they've got the normal stuck mechanism, but they can also generate thread dumps. And this is kind of JDK kill -3 level thread dumps, which you don't necessarily get from other tools on the IBM JDK. So it generates a thread dump whenever you encounter a stuck thread, so you can see exactly what all the other threads were doing as well. And they even go one step further, so they've got a kind of a monitoring mechanism for the thread that's monitoring the stuck threads. So it's I don't know. So it's a bit. You have to make up your mind whether they don't trust their own code or whether they just wanted to build a really robust mechanism. But there you have it. So they can also generate thread dumps whenever the monitoring mechanism goes bad. Speak to me if you want to find out about any of the other app servers and how to enable that. And then another technique that's essential is monitoring CPU usage. So a tool like Dynatrace will be able to help you with that. But let's go to the more bare bones kind of techniques. So in Windows, you've got a couple of ways of doing that. On AIX, you've got their version of the top command, and you've got nmon that you can use. And then on Linux, you've got a whole host of options. You've got top, you've got a specialized command of htop. You can do a PS with some fancy command line foo again. Or you can, if you want to use a GUI, you can even use a GUI. So there are lots of options, and again, by no means exhaustive list of options. So this gets me to the first kind of campfire story. So why fix it if it isn't broken? So in a lot of our environments, there's this tendency to, if something's in production, been in production for a while, you don't really want to throw over the apple cart. You don't want to disrupt things. You just, if some version of software is working, why change it? Well, I'm going to show to you in this case that it's almost always a good idea to change the software and keep up with the latest versions provided you have tested in your environment. So what we saw was, after we did a release, and when we monitored the CPU, we saw that the Java process was sitting at about 94% CPU, where prior to this, it was humming along at 30, 40% of CPU. So obviously something had gone wrong. What was that? So while looking at the log file, so this is where looking for the word stuck comes in. So we're looking at threads that are running for longer than 60 seconds. And in this case, we've got hash map code, and which is in turn being called by WebLogic rendering code. So in this particular environment, we're using WebLogic Portal. So these COM-BA NetUIX classes are WebLogic Portal classes. and they were using a hash map. So at this point, we went to the Oracle knowledge base, and we found an exact match for what we saw in the stuck thread. So this is from the knowledge base. So if you see that, and you see that, then you know you have a match for this problem. So it was 100% the same thing. And it turns out that there was an unsynchronized usage of a hash map in the WebLogic portal code, which we were running on version 10.3.2, and this had been fixed in version 10.3.4. And this is, by the way, is something that I've seen happen lots of times in vendor code and in our own developers' code. So where hash maps, it's one of the most frequent things I've seen where hash maps are used in a non-thread safe manner. So you're not using a concurrent hash map, or you're not ensuring that you're locking the hash map in another fashion. So be aware of that. And what had happened here was we deployed software that was just business as usual. There was nothing funny about what we were doing. It was just a couple of web pages. But because of the timing that this introduced, it has caused this problem to pop up. So in this case, we didn't do anything out of the ordinary. It was just lurking there the whole time and waiting to bite us. So be careful of staying on the same version of the software. So like I said, upgrade to 10.3.4, and that immediately sorted out the problem. Then the next campfire story, it's timeouts for quiche eaters. Now, if you don't know what the hell I'm talking about, well, this goes back to the day of when you had real programmers that used languages like Pascal, like assembly and Fortran and so forth, and then you had the quiche eaters who used languages like Pascal, and they were seriously pedantic, and you had to do all kinds of strange assignments of variables and so forth. But what New Relic, and you've got Riverbed, those four are, according to Gartner, the top four in the APM space. So they're the big boys when it comes to application performance monitoring. The two I've used before is Dynatrace and New Relic. I haven't had a lot of experience in the others. What I can tell you about New Relic is the way they record the data is it's always sent to the cloud, so you don't have an option to locally run your server, and that might be a problem for a lot of South African corporates and big companies. Okay, so we've got our tools starter pack. How do we generate heap dumps? Well, so you can use one of those tools, or you can use your application server's admin console or command line interface, or you can use your JDK's JMap command. That will also generate one for you. You give it a process ID, and you've got even more options. So you've got if you use some JVM startup arguments, and then a kill -3 or control break, you can do it on demand whenever you need to. Or some JVM startup arguments and some condition, like an out-of-memory error, will automatically generate your heap dumps for you. By the way, a lot of these functions you don't really need to do if you've got something like a Dynatrace, because everything is kind of brought together in one convenient spot for you. Generating thread dumps, so that's very much the same. Same options. There's one exception, so you use JStack instead of JMap to generate the thread dump. Which brings us to another one of those campfire stories, and this is, I think, my favorite. So this is the curious incident of the string builder key in the nighttime. So what happened here? So we used, you've got your profiling tools, and by the way, again, there's a lot of other profiles that you can also use, which will be covered in some of the talks tomorrow. And this brings us to Dynatrace. So in this environment, we had Dynatrace deployed. You've already seen the hotspots by API screenshot. So this is not the actual screenshot, but we saw something like this. So we saw one particular package, Java package, that was taking a lot of time. We drilled down, the moment we drill down into that, so we saw that, something like that. Drill down into the top one, and what we found that there was a Oracle coherence cache method that was being called quite frequently. So the app server was spending quite a lot of its time on that particular call. So let's just zoom in on that. So that's property group. So we're using the cache for sort of generic configuration properties, and it was doing that an inordinate amount of time. So what is Oracle coherence? Well, it's one of the so-called in-memory data grids. So if you've had any experience with any one of those, you kind of have an idea of what it is. But for purposes of this, let's just say it's a distributed key value map. It's not quite just that, but let's just say it's that. So in the hotspot profile analysis, we saw that there were 2 underlying caches for that particular method, and they were both distributed caches, and they had less than 100 cache entries each, and the cache entries looked like they were primitives or strings, so no complex objects were stored in the cache. Which then made converting those, because distributed means it gets replicated among a large number of cache nodes. So you've got separate JVMs being used for your cache storage, which didn't really make sense for a cache like that. It's something that you could actually move to a local cache, so that it runs locally within your portal server, your WebLogic portal server. So we made the decision to apply the fix, so we converted that to a local cache. In this case, it was we should have run a load test, but in this case, it was very difficult to replicate a load test, and it still is. There is no easy way with the actual all the back-end and third-party interfaces that we're calling to do a complete full load test of the entire environment. You can do it for certain sections, but not for the whole thing. Had we done that, we would have discovered some things earlier on. So in absence of a proper load test, we did do a small load test, but not the proper one. So production deployment, here we come. So everything went all right, and then 5 o'clock the next morning, we could see, I don't know if you can see that. No, you probably can't. But basically our heap usage was going crazy. So we were running out of memory, and you could see that by the time we started taking full load, which was around about 8 o'clock, that we were going to completely crash out of memory errors, all the servers down, the entire production cluster down. So we had to switch over to our failover cluster and go lick our wounds and see what was going on. So what did we do? We took a heap dump, and we pulled it into a tool called Eclipse Memory Analyzer. That's one of the. Also, if you've got something like a Dynatrace, you can use that. But in this case, it's an open source tool. It can read both IBM JDK and Oracle JDK dumps. It's pretty much the only heap analysis tool I've ever had to use or ever needed to use. And what we saw there when we opened up the heap dump, by the way, this takes about 10 minutes to open up. So if you've got big heap dumps, it's quite intensive. What we saw was that we had a local cache that was 1.5 gigs in size. So what that was, because I mean we had a cache that was 100 entries in size. So why was it taking up 1.5 gigs? So drilling down further into the data, we saw that we had a cache key in that 1.5 gig cache keys that were string builders instead of strings. So then going to the string builder Java docs, you'll see that actually the equals in the hashcode method, they come from Java lang object. So how did that ever work? Because it was in production for 2 years. What is going on here? So turns out that the distributed cache compares the serialized form of the keys, which in this case will be the string builder serialized form, which will be the string. So in this case, it looked like it was the same. But if you convert it to a local cache, it functions more like a hash map, that it uses the equals and hashcode methods to determine whether there's equality. So the whole time it was thinking these items haven't been added to the cache yet, and was just kept on re-adding them. So it was great fun was had by all. Okay, so what was the real fix? Well, it turns out it's pretty much, as with most of these things, it was about 2 lines of code, where instead of then using the string builder
as the key, we just did a toString on the key on the string builder object, and then when we retrieve it, again use the string instead of the string.
Some guys are like not for that.
So I have a nice non-relaxing December. Then getting to the next one. Next campfire is already mixing software vendors. It's just like mixing your drinks. Always seems like a good idea at the time, but then the next morning we have a bit of a hangover to deal with. So again, we had some coherence crashes. This time actual. And then, by the way, by this time you might be wondering if coherence is actually something to steer away from or not. It does pop up quite often in this talk of mine. It's an excellent product. but you will get the same effect if you take developers and you say to them, here's your Oracle database, you are now going to be an Oracle DBA. You know, so eventually they'll manage, but you're going to have some teething pains. And same thing with Oracle Coherence. It's a massively complex product, so you need to be sure of what you're getting yourself into. So we had crashes of our coherence instances of the cache storage nodes. In this case, we took some thread dumps. Well, actually, we didn't take them; they were automatically generated. Because if you so this is sorry, just a step back. But this is IBM thread dump analyzer. So it's an IBM tool. It seems to be something that kind of was written on the side by somebody at IBM, but also you can read both IBM JDK and Oracle JDK thread dumps with that. Looking at the bit in red, you'll see that there was a deadlock detected in the CompTangosaur. And by the way, CompTangosaur is one of the packages for Oracle Coherence itself. The deadlock there. And looking at this is the monitor lock. So this is which locks are being held and in turn which other threads are waiting on these locks. So looking at the detail for that, the parent you've got there is CompTangosaur refreshable address provider. If you go into the actual thread detail for that, you'll see that that's at quite a low level in the JVM. So it's a Java Lang thread group that it owns the synchronized block. Then looking at this packet publisher, again this is in Java Lang thread group.check3thread, so that's waiting on the previous parent. And then when you look at the next one in line, it's again the first one, so you've got sort of a circular type lock pattern going on here. And again the same one, so that's the same as the second one, so fourth and second one are the same. So just to recap, deadlocks, how they cause. Well, it's when you've got one thread that's holding an object and it tries to get a reference to another object. At the same time, you've got another object that's also holding a lock on the object that the first thread is trying to get a hold on. And at the same time, is trying to get a lock on the first thread's object. So you've got this deadly embrace that you'll never get out of. In Java terms, what we call this is if you're using the synchronized keyword, if you've got 4 occurrences of that, that's enough to cause the deadlock. And there are other ways, obviously, to get that resolved with different kinds of blocks and new texts, but that is one of the ways, and that's what happened here. So what's going on here? So, well, it turns out that we've been using Oracle App Server, Oracle Coherence, which was running on the IBM JDK, which was running on AIX. And it turns out that the IBM JDK has 3 out of those 4 synchronized points inside its internal threading code. So in Java Lang thread and thread group, you had 3 synchronization blocks that didn't exist in the Oracle JDK. There was no equivalent for that. So they had a completely different route when they implemented that. So this was a condition that would never happen in the Oracle JDK, but because we were running on IBM JDK, this is what we said. And after about 3 months of back and forth between us and Oracle and IBM eventually agreed that yes, it is a problem with JDK and provided us with Flash. So just be wary. We can make it work. I mean, I know some other guys that run they run WebSphere on Solaris. So you end up with all these legacy things. I think we actually needed to trade with those guys. Just trade hardware and software at some point and see where we get to. But yeah, anyway, just watch out. The garbage collection. Andrew touched on that sort of very quickly. It's something that we can probably do like a whole very boring read of lectures on garbage collection. But what I just want to highlight is for both GC logs. So that kind of is an indication of what's going on in your garbage collector. How do you switch them on? That's how you do that in Oracle JDK. So it's quite verbose. Following the fun, and then you've got the IBM way, which is kind of shorter, so that's all you need to do to generate with both GT logs. So how do you analyze them? Well, the most obvious way is to again open them up in a text editor and read some docs and find out how your garbage collector works. That will give you the best understanding of what's going on. that idea of getting under the hood and exactly not having to deal with the black box. So by hand, or you can use something in the tool starter pack. So the tool starter pack will automatically look at your GC stats for you. You don't need to even generate those GC logs. It will handle all of that for you. Again, an IBM tool that's manages to also work with the Oracle JDK. And again, you've got a lot of variety in tools that you can choose here. This is just what works for our environment. There's another IBM tool. Which gets me to the next campfire story. So Java serialization is built into the JDK. So I'm sure you that we've done homework, which just worked great. So what we did in this case is take those GC logs, pull that into one of those IBM tools, and can you guys see what's going on or not really? Okay, so basically what you've got there is you've got this sawtooth pattern, which is it's usually a good thing, well, depending on your app, but it's in most apps cases it's a good thing when you've got the sawtooth of a major collection every now and again. But what will happen here is this major collection happens every 30 seconds. So and then you had a stop the world pause of say 5-6 seconds, which is horrible. You know, that's completely kill your application. So how do you analyze, or how do you identify large memory allocations? You can do it by enabling a couple of settings on the IBM JDK, which will dump large allocations to log file. You can do it using Java mission control, that will give you some nice insights. Or you can use a commercial APM like a data trace or really. There's an example of the Java mission control, what it looks like. There's an allocation of 750 kilobytes. So what happened in this case? Well, it turns out that there was a certain bit of business functionality that required deal sheets. And these deal sheets were cached, but they were cached as a single object. So initially, and the business requirement said there will only ever be 400 of these on the deal sheet. But obviously, it's a bad design to take an object containing 400 deal sheets and plonk that into one cache item because you're serializing this giant object every time. So the architecture from the beginning was problematic, but to make matters worse, by the time we looked at that, there were about 7,000 to 8,000 of these deal sheets being loaded into this object, and it was creating a 7 meg object every time you tried to serialize that. And to make things even worse, this functionality was being used a lot more than it had been previously. So it was being called from all kinds of different pages, from a landing page. It was basically the server grinds to a halt. The moment we deleted some records from the deal sheet database, and it didn't load into the cache, all of a sudden you could read. So we had a kind of a problem on our hands. We didn't have a very easy, quick fix. So we needed something to just kind of keep us going until we could sort out the underlying architectural problems. So I had a look at different serializers, and if you look at the bottom here, this is your deserialization. That's the Java built-in performance, and then you've got a serialization library called Cryo up there, which seems a heck of a lot better. A lot of these needs a lot of extra work to make things deserialize, generates code for you, and you have to write it into bojos and all kinds of things. But Cryo just works out of the box. So just looking at your size as well, Cryo 212 bytes for an object, and Java built in 889 bytes for the same object. So it's definitely a huge improvement. So what we did was we just quickly swapped out the Java serialization with Cryo serialization, and we could actually stay afloat for a while until we managed to get the proper fixing. Then JMX and MBeans. So JMX, that's one of I think the last technique that I want to quickly highlight. Java machine control. So what are JMX and MBeans? The JMX stands for Java Management Extensions. So it's a way of monitoring what's going on inside your app services and your Java applications. It's a standard, so you've got multiple agents that can connect using the same standard, same protocol. And MBs are the objects that expose your metrics about your app server. So you use that to expose your CPU, heap size, that kind of thing, and various other JDBC connection tools. You know, in this case, this is a screenshot of Java Mission Control, where I'm highlighting what's the different properties on a specific JDBC resource. So it shows things like your max capacity, your minimum capacity, how many active connections you have, all kinds of things like that. It's a way of gaining insight into what's going on in your app server, and it's also something that's used by tools like Dynatrace and there's other tools to query your app server and draw nice graphs with you and show you what's happening over time. You can also usually view this on your app server's administration console. So there are a lot of different ways to get to the same info. So like I said, these in-memory data grids are basically just that. So you just plonk them in there and magic happens. So what we have here is, so we've got a virtualized AIX environment. Sorry, virtualized PowerPC environment with different logical partitions. And what this is the usage on the CPU pool. So for this logical, this virtualized machine, you've got a CPU pool that they will all pull from. And you saw that before this deployment, CPU usage was sitting at around about 12, 13, 14 CPUs, and by the end of it, we were sitting at around about just below 30 CPUs. So a massive jump in CPU usage. And of course, the problem with this is for a lot of these products, you pay per core that you use. So immediately your licensing jumps straight up. So what was going on here? We had a look at in the case of coherence, again, coherence, our constant friend. Coherence has a way of
reporting on your JMX extension. So you configure it to write your JMX bean values to a file. So that's what we did in this case. This was before we had Dynatrace, by the way. If we had Dynatrace, this wouldn't have been as much of an issue. What we saw was that we had a specific cache that had around about 3 million gates in the space of about a minute. And definitely, it was quite a hot cache, but it was not supposed to be anywhere near that hot. So then we had a
bit of a look around and looking at some of the other JMX MB properties. We saw that there was you've got a max query description. So if there's item, the one is to validate by key, and the other one was to validate by dependency ID. So you would group a number of cache items together, and then when you want to validate them, you just validate by the dependency key, the dependency ID, and then you just validate all of them in one go. So one uses information, for example.
Acts more like a database.
And the code that would do that what it did was it would use this contains filter to determine your get dependency ID. And first off, it uses reflection over there. So this is the actual method that gets the dependency ID from. But then, if your code's not indexed, or if your cache usage is not indexed, what it does is it actually goes each and every single record in your cache, it will deserialize it, call that getter method, see if it matches the dependency ID, and then it will only then invalidate that, determine it as part of the filter collection. So, and then it was also doing this multiple times every second.
First off,
so the fix for this, quite straightforward in there. What we need to do is add a dependency ID extraction. So something that first off extract the dependency ID without reflection. So we do need the reflection.
Every single record
and it also would have a certain hash code so that if we apply this dependency ID extracted to the cache multiple times, you know that it's already been applied once. It's already got this ID, or this index effectively, and it shouldn't add it again. and then looking at the actual code, so there you get your cache reference, and we'll add an index using that dependency ID extractor. And you can do this multiple times, like I said, so you can, doesn't matter where you, because you can be pulling from lots of different places in code, getting the reference, saying this is the index I'm using, and it won't matter because your equals and hash code methods point to the same place. And then the actual methods implementation changed somewhat. So you've got your contains filter that now doesn't use the reflection, but it uses that extractor. You'll see there's some logging that we're printing out there. I'll get to that in a bit. And then we just filter using that contains filter and remove all those keys with the dependency.
And you can do this multiple times, like I said. So you can, doesn't matter where you, because you're pulling from lots of different places to code,
if you've got any DBA type inclinations, or if you're a developer and you use databases and you don't know what this is, then we also might have to have a chat. Because this is kind of like almost exactly like an explain plan that you would run on a database query, a simple query that shows you the exact path that your query uses to resolve the results. Does it use an index? Does it do a full scan? How does it resolve that? So it's more and more looking like a database, a traditional database, be it an in-memory one.
Got any DBA type inclinations, or if you're a developer.
And then just to make sure that we've sorted out the problem, had a look at the JMX console after that, or the J console, and you'll notice that there aren't any non-optimized queries. Every single one of the database query
that shows you the exact.
And obviously you can see that from the CPU
query uses
returning to normal.
The results. Does it use an index?
So wrapping it up.
How does it
build your toolbox? So every environment is different. You need to find the tools. I've shown you something that will work in that particular environment with the mix of the IBM and the Oracle tools, but each environment is very different, and you need to really identify some tools that you use as your go-to tools, and right away when there's a problem, you know this is the set of tools that you're going to use. Like again, to reinforce there are many ways to skin a cat, many ways to actually get to the same root cause, and make sure that you do get to the root cause, because a lot of times you look at something in the log file and it looks like
every environment's different. You need to find the tools. I've shown you something that will work in that particular environment with the mix of the IBM and the Oracle tools, but each environment is very different, and you need to really identify some tools that you could use as your go-to tools, that right away when there's a problem, you know this is the set of tools that you're going to use. Again, to reinforce that, many ways to skin a cat, many ways to actually get to the same root cause, and make sure that you do get to the root cause, because a lot of times you look at something in the log files and it looks like this is something, or you hit the first thing in a log file and you see some sort of exception, you think, oh, this is it, but very rarely is that the case that you've identified the problem. It's usually a case of kind of digging around in finding a needle in a haystack, that kind of thing. So and it's something that only comes with experience and doing this a lot of times, where you eventually start getting a feel for what might be the real cause and what might not be. Like I said, consider all the angles. Don't take the very first thing, and then protect the many at the expense of the few. So obviously you would like to grant service to all of your customers, but if it means that you've got something that's not timing out, and that's actually bringing down your app service for only a small percentage of calls, then you're putting everybody else in jeopardy while you're serving these few customers. So make sure that you do keep the server up at all costs, even if it means denying service to some customers. Look beyond the JVM. So this talk very much focused on what's going on inside your JVM. Look at things happening on your operating system side. I mean, if I had a RAN for every time that a server ran out of disk space, I'd probably have like about 100 RAN right about now. So just be aware of that. Look at your TCP/IP tuning, buffer sizes, all kinds of things like that. I mean, and that's also sort of a field of study on its own. Sorry, and also on beyond the JVM, look at your networks. Look at what's happening on the network side. Understand how to use a tool like Wireshark, for example. Get to grips with the lower level protocols. And then lastly, test and do some more testing. So test your code changes. This is where if you wrote your unit tests and your integration tests and you automated everything, this will be really helpful, because at that point where disaster hits, you need to get it out into production quite quickly. So if you don't have unit tests, it's going to take you a lot longer to actually verify that your code changes have not broken anything else. Test your configuration changes, like I mentioned. Beware of where the documentation doesn't match the actual behavior. Do benchmarks. So these are so you can do micro benchmarks where you just write a small Java application to kind of simulate the behavior that you're seeing and the fix for that. So that would be step number one. And at that point, integrate that into your app server application. Take it to kind of a bigger platform and run the same kind of benchmarks to see that you're getting the desired results. And then run those load tests. And I think that's pretty much that. So if there are any questions, or shall we keep it for the panel?
Yeah, if we can just have the speakers up there quickly.
Okay, cool.